Then the second learning objective is the linear demand function. This is where we're going to try to quantify demand. And here we have an expression that is linear, which shows multiple factors. So we have the variables of price of X, price of Y, income, and other factors. Let's look more closely at this demand function and notice that the alpha coefficients are quite important, that they each quantify the magnitude and the direction of each of the variables that we've specified. For example, if alpha X, which is related to the price of X, if it is less than 0, that means that it's a law of demand, such that if the price of X goes up, then the quantity would go down, right? Because it would become a negative factor, reducing the amount of quantity. And on the other hand, if the price goes down, then the negative of alpha X would cause the quantity to go up, right? So this is a normal, what we'd expect to see from the law of demand. Now, the next one is more interesting. This is the price of Y, the related good. If the price of Y goes up and it is a substitute, then AY must be negative number, because if the price of Y goes up, the quantity of Y goes down, and if the quantity of X goes up, then it's a substitute, because people are substituting X in replacement for Y. So a positive number in the alpha Y coefficient means that X and Y are substitute goods. On the next one, which is the alpha for income, if this is a positive sign, that means that as income goes up, we buy more. That is a normal good. If it's a negative sign, that means if the income goes up, that's going to reduce the quantity. That means it's inferior good. So here's an exercise we'll do on linear demand. We'll go into Excel, but let's first look at the problem. So let's say we hired a consultant who derived this demand function for us. Isn't that convenient? And it has the quantity of X demanded equals this multiple factor formula. The question is, how many of good X will consumers purchase if we are given these parameters? And then determine if X and Y are substitute or complements, and is good X a normal or inferior good? So let's go to Excel. So the first thing we do is quite simple. We just substitute the known values. So it's just equal 12,000 minus 3 times px. Px is given at 200 plus 4 times py, which is given to us at 15, minus 1 times income, which is given to us at 10,000, plus 2 times a, which ax rather, which is 2,000. So the answer is 5,460 items which would be sold. So that's how much we would sell. These are measured in units of product or good X. Next are goods X and Y substitutes or complements. And again, all we have to look at is the sign in front of the factor for P sub Y. So here we see that it's a positive. Again, let's go through the scenario. If the price of Y goes up, the quantity of Y goes down, and yet the quantity of X will go up because it's positive. So therefore, it is a substitute. And that's since PY has a positive coefficient. Next is, let's look at normal inferior good. For that, we look at income. And again, we'll look at the factor in the coefficient in front of M. It's a -1, which means if M goes up, the quantity goes down. That makes it an inferior good. If we're a normal good, as M goes up, quantity go up. So this would be a positive sign. So negative tells us inferior good. And it is a negative coefficient for income. All right, so that's it for that exercise, and we'll just go back to our slides. Next, we'll simplify the demand function. First, we have our basic relationship, has multiple factors, and then let's say that we know certain factors, and we'll substitute the price of Y at 15, M, which is income, at 10,000, A of 2,000, then we can simplify down to a term like this, where we'll have one variable here, which is the dependent variable, quantity demanded of X, equals a constant, and the only variable left is price. And that is a demand curve, right? We're relating quantity and price. So if we solve for price, that is the vertical axis. So we solve for price as an expression with the horizontal axis determined by Q, right? The quantity of X demanded. So this is a demand function, and you see the negative slope. That means it's an inverse and it's a downward sloping demand curve. So if we look at the graph for this, it would look like this. The higher the price, the less volume, and the other side is the lower the price, the more volume. The equation that we just carried forward is 2020, which is the intercept on the vertical axis, and then the negative slope means it's downward sloping at a rate of 1 divided by 3 for every unit we move to the right. The price will drop by 1/3 of a unit, or 1/3 of a dollar in this case.